I'm Andrew.
I'm Sami.
And I'm Ajay, and we want to introduce you to the Forecast package in RStudio. The Forecast package has tons of unique features and functions that we want to talk to you about. But first, what is this package? Well, the Forecast package is used as a method to display and analyze time series data such as the stock market, weather patterns, and if you took STAT331, the time management project.
Outside of Cal Poly, the forecast package is often used in business settings to explain the seasonal pattern of sales, to predict the expected number of incoming customers, or even estimate the effects of newly launched products on sales. Some of the most common features of the forecast package are its graphing abilities of various plots. We have broken down the package into some of the most common graphical displays and functionalities just for you.
Now, it'd be pretty boring if we simply showed you every function and what it does with a meaningless data set. So we decided to involve Johnson & Johnson. Yep, that's right. We're going to use earnings per share data for Johnson & Johnson from 1960 to 1980. Because who doesn't like all that baby lotion, biotech, face wash, and other consumer products?
Our first step is to obviously open RStudio and install the Forecast package. Next, we'll open the package and load the Johnson & Johnson data so you can see what we're working with.
As you can see, because the data comes from an already built-in RStudio dataset, the data is neatly organized into unique rows and columns, each displaying just one data entry, making our lives a whole lot easier.
Perhaps the most important function in this package is forecast. The forecast function takes in your data set as input and returns a prediction for the future. So in our example, it is using all the data from 1960 to 1980 to make a prediction about the estimated quarterly earnings per share for Johnson & Johnson over the next 8 quarters. The result displays two prediction intervals, one of 80% confidence and the other of 95% confidence. This functionality can assist traders in making decisions concerning whether or not to invest and help predict returns.
The forecast function can also take as input the number of periods for forecasting, different confidence levels, use adjusted means and fitted values, as well as adjust to missing values, outliers, and more dominant time periods. With a data table like Johnson & Johnson, it is common to know the frequency distribution, so that is where the GG histogram function comes in handy from our package. Just like before, simply call the function and insert the name of the dataset.
As you can see, the most frequent values from the data are between 1 and 2. Also, notice that the graph is skewed to the right, indicating that the mean is being dragged higher by greater values, but is also indicating that there is more to the data worth exploring.
This is where a cool function like GGTS display comes in handy. This function takes the dataset as input and produces a graph with the years of our dataset on the x-axis and the quarterly earnings on the y-axis. Additionally, an ACF, autocorrelation function, and PACF, partially autocorrelation function, are created, making it possible to assess the presence of trend and seasonality in the dataset. Notice that there's an upward trend in the time series plot, as confirmed by the ACF decrease as lag increases. In STAT331, you will learn about time series plots. This package makes creating these plots much easier than in base R.
Pretty neat display, right? Now we can see that over the course of this 20-year period, the quarterly earnings of a Johnson & Johnson share has increased tremendously. Now a common statistical method people inquire about is residuals. Not only do residuals pertain to statisticians, but also people who take interest in knowing the difference of what he or she predicted to happen and what actually happened. Luckily in the forecast package, we can call the check residuals function on an ARIMA model and see the graphical display of the differences. An ARIMA model is an autoregressive integrated moving average.
From this plot, we see the differences in residuals are both positive and negative, meaning that the quarterly earnings per share of Johnson & Johnson return both more and less than what was predicted at various times. If we wanted to dig a little deeper into the data and find out the growth by quarter, well, we couldn't do that too easily with base R. However, Forecast package offers a simple method using the GG month plot. Once again, our only input is the name of the data set and the function returns a graphical display.
The GG month plot graphed by the data by quarter, and on the y-axis we can see the values of the quarterly earnings per share. The blue line in each display represents the mean quarterly earnings of each time period. Instead of breaking down the data quarter by quarter, we can also easily break down the data by year using the GG season plot, passing the name of the dataset as an argument.
Just like we had suspected before, the quarterly earnings per share of Johnson & Johnson increased every year from 1960 to 1980. As we have demonstrated, not only does Forecast package bring additional functions such as forecasting quarterly earnings per share, but it also makes many base R processes less complicated and more user-friendly. If you wish to learn more about the forecast package and functions, simply search CRAN forecast package and click the PDF link. Thank you.